This conference will now be recorded.
Fine. So far, we're done with 2 hours of sessions. In the 2 hours, first in the class one, we have introduction to Power BI. In the class one, we discussed about introduction to Power BI. And in the class two, what we discussed? In the class two, we seen how to install the Power BI desktop software. Everyone, I hope everyone installed it. If not, please install the software as soon as possible. So yesterday I shown you how to install Power BI desktop software. And once we install Power BI desktop software, we understand what we will do in Power BI desktop. I explain at a high level what we are going to do in Power BI desktop. Once after explaining what we will do in Power BI desktop, we see an overview of Power Query software. So what is this Power Query software? What we will do with Power Query software, we seen guys. In the last 2 hours, this is what we discussed. Today's class is class 3. So the agenda for today's class is we'll understand overview of Power Pivot software. Yesterday we seen what we will do in Power Query. Today we are going to understand about what? Power Pivot. Once you install the Power BI desktop, you'll see a shortcut like this. How to open Power BI desktop? Double click on it. It will open the Power BI desktop software. It will open the Power BI desktop software. Once it open the Power BI desktop software, first thing you will get is you will get a start screen. I said that just close the start screen. We are not going to do any development here. Once you close the start screen, you will be landing in the report view. From here, how to open Power Query software? Go to the home tab, click on transform data. Once you open the Power Query software, how to bring the tables into the Power Query? New source. You need to click on new source. First thing we need to do is we need to connect to the data sources where our clients are storing the data. We need to bring the tables. So yesterday I shown you how to bring the tables from Excel. Click on new source, click on Excel and browse where the Excel file is located. Where the Excel file is located and select the Excel file and click on open. It will show the list of tables you have in that Excel. And you select what tables you need for analysis. What tables you need, you can select and press OK. The tables will come to Power Query. The same way I want to bring the tables from a SQL Server database. How to bring it? Click on new source. This time you need to choose what here? SQL Server, SQL Server, and you need to give the server name and database name. Our clients will provide us. Let me provide the server name here. This is a server from where I need to bring the tables. Select the server name, and I want to give the database name also here. So database name, as it is optional, I can press OK. It will show the list of databases we have in that server. 5 databases are there. When you expand any database, you can see the tables in it. So I want to analyze product database tables, customers table, products table, and sales table data. I selected the 3 tables. Press OK. Like this, you can go to any source, you can bring the tables. And I want to bring some more tables from another Excel file. How to bring some more tables from another Excel? Again, new source. Click on new source, Excel. This time, sample superstore. Click on open and select what tables you need for analysis. Press OK. Like this, you need to go to each data source. You need to bring the tables, guys. Once you bring all the tables into the Power Query, you need to go to each table and you need to see the data. If required, you need to transform the data in the tables. In the last class, we seen in the customer table, I need customer full name column. I want to combine first name, middle name, last name. I need full name. So to combine the 3 columns, what option we used? In the add column, merge columns we used. Click on merge columns. Separator I want is space. The new column name is I want is customer full name. When I press OK, you got a customer full name column here. The same way in the product data table, yesterday we converted product name to uppercase. As client asking to show product name in the uppercase, you select this in the transform tab under format. You have uppercase. We click on uppercase. It got converted to uppercase. Like this, we went to each table. If there is any transformation required, we transformed it. In the returns table, the first row is not data, it is header. I want to move it to the header. I went to home tab. I click on what? use first trace header. In the orders table, I have proper formatted data. I don't want to do any transformations. In the people's table, the first row is not data, it is header. I want to move it to the header. Just go to the home tab, click on use first trace header. Like this, you need to go to each and every table and you need to transform the data if required. Once you are done with transforming the data, how to load the data? Click on close and apply. Till here we discussed in the yesterday's class, guys. Extensively, we'll discuss for 40 minutes how we will perform the ETL work in the Power Query software, guys. Once you are done with ETL, you want to load the tables to Power Pivot. When I click on close and apply, all the 9 tables will be loaded to Power Pivot. Click on close and apply. The 9 tables will be loaded to Power Pivot. Now we'll go and understand what Power Pivot is. First thing, let me define what Power Pivot is. Fine. Whatever the tables we loaded from Power Query, where we can see them is model view. There is a name called what? Model view. You need to go to model view and you can see the tables what we loaded into Power Pivot. When I go to model view, I can see all the tables which I loaded here. I loaded totally 9 tables. I'm able to see all the 9 tables here. We'll come here. Before that, let's talk about what Power Pivot is. So let me define what Power Pivot is. Power Pivot is a database. It's a database where we will create an OLAP model. We'll create an OLAP model. If someone asks you what Power Pivot is a database, guys. How Oracle, SQL Server or databases, even Power Pivot is also a database. What is the purpose of database? To store the data. Database is used to store the data in the form of what? Tables. In the form of tables. Database will store the data in the form of tables. Even Power Pivot will store the data in the form of what? Tables. Power Pivot is also a database. When you install Power BI Desktop, you will get this database automatically. Whatever the tables you bought it from the source, whatever the tables you loaded into the Power Pivot, the tables will be stored in the Power Pivot. As it's a database, its core functionality is to store the data in the form of tables. Once we load the tables, there we will create a OLAP model. You will understand? Okay, fine. We understand that Power Pivot is a database. So it is not a normal database. It's a in-memory database, guys. There are 2 types of databases in the market. One are relational databases. There are 2 types of databases: relational databases or in-memory databases. In-memory databases. One thing you need to understand is Power Pivot is a powerful database when it comes to reporting, guys. So what I mean to explain is, in the SQL Server also, you will have the tables, you will have the data. In Power Pivot also, you will have the tables, you will have the data. In SQL Server, you have the tables and data. In Power Pivot also, you have tables and data. You have tables and data. So both the places you will have tables and data. When you create a report on SQL Server, when you share that report with your client, you can directly create the report on SQL Server. You can share that report with your client. When you do that, when client open the report, let's take an example. It is taking 60 seconds of time to load the data into the report. Every time when client open the report, it need to take the data from SQL Server. It need to show the data in the reports. For that, how much time it is taking? 60 seconds of time it is taking. It contains huge volumes of data. To show the data in the report, it is taking 60 seconds of time. The same data I'm storing in Power Pivot. The same data I'm storing in Power Pivot. On the same data, I'm creating a report. When I share that report with my client, when my client open this report, it can show the data within 10 seconds of time. It's also database. It's also database. Here also you have tables and data. Here also you have tables and data. You can even create the reports on top of it. You can even create the reports on top of it. What I mean to tell here is, when you create the report on Power Pivot, when client open the report, he can see the data quickly when compared to this. How? So SQL Server comes under a relational database, a Power Pivot comes under a in-memory database case. There are two types of database. When you create the reports on top of in-memory database, the performance will be good, guys. The same report which is taking 60 seconds of time, when I open the same report here, when I take the data from Power Pivot, when I show the data in the report, it will show in 10 seconds of time around. How? So there are two types of databases, relational database and in-memory databases. Examples for relational databases are Oracle, SQL Server, etc. SQL Server, etc. Examples for in-memory database are SAP HANA, and Power Pivot, etc. Power Pivot, etc. So how in-memory databases will give better performance when you do the reporting? So I said that when you do the reporting on in-memory database, it will show in less time. How it will give that much better performance is when you retrieve the data from relational database, it will give the data from hard disk case. When we take the data from relational database, when we query the data from relational database, they will process the data from hard disk. They will process data from hard disk case. Hard disk. When you query the data from in-memory database, when you query the data from in-memory databases, they will provide the data from RAM, guys. They don't provide the data from hard disk, they will provide the data from RAM. So relational database, when you take the data, it is giving from where? Hard disk. In-memory database, when you take the data, every time it will give the data from RAM, guys. Which one will be faster? There is no doubt RAM is tens of time faster than hard disk. RAM is tens of time faster than hard disk. This is the first point why you are getting that much performance is in-memory database. Power Pivot is an in-memory database which can process the data always from RAM. When you open the report here, client, when you create a report on Power Pivot, when you share that report with your client, every time when client open the report, the data will be processed from RAM. When it is processing the data from RAM, the client can see the data in the reports quickly, right? Okay. And not only this, guys, the architecture of relational database is completely different. The architecture of in-memory database is completely different. There are some more advantages with in-memory databases. Not only processing the data from RAM, there are some more advantages with in-memory databases. What are the some more advantages is? So let me show you here. So in the relational databases, the data will be stored in the row format case. So just understand the way the data stored in the relational database is different. Relational databases, people also call it as traditional databases. Traditional databases or relational databases. The way they store the data in the traditional databases or relational databases is different in the row format. So let me write here. Here the data will be stored in the row format. But when it comes to in-memory databases, the data will be stored in the columnar format. Columnar format. What is this? What is row format? What is columnar format? I'll explain in the coming classes. When it stores the data in the columnar format, we have a lot more advantages, guys. When a database stores the data in the columnar format, we'll have some more advantages when it comes to reporting. What are the advantages you will have is, one advantage with columnar databases, columnar format is data size will be highly compressed, guys. In columnar database, data will be highly compressed. Highly compressed. The meaning is, I'm storing some data in the SQL Server. I said that SQL Server data will be stored in the row format. When it stored the data in the row format, it will occupy more space. So let's assume I'm storing some data which is occupying 100 GB space, guys. So when I store the data in the SQL Server, how much space it is occupying? 100 GB space. When I try to load the same data into the Power Pivot, same data in the Power Pivot, the data will be stored in which format? Columnar format. Columnar format. So when we store the data in the columnar format, the data will be highly compressed. Compressed means, will the data size reduce or increase? reduce. Till what extent it will reduce is 1 by 10th of source data, guys. It will reduce to 1 by 10th of source data. It will come to what? 10 GB. When you try to store the same data here, if it is occupying 100 GB, it will occupy only 10 GB here. So how the size will come to 10 GB practically, I'll show you guys. In the coming classes, why row format will occupy more space, why row format will occupy more space, and why columnar format will occupy less space, I'll discuss. One advantage with columnar format is data will be highly compressed. If SQL Server is taking a space of 100 GB to store some data, when you try to store the same data in the Power Pivot, it will occupy only 10 GB, guys. 10 GB, approximately 10 GB. This is one more advantage, guys. How much space you are saving here? 90 GB space I'm saving in the Power Pivot. The second advantage with columnar format is when you perform any aggregate calculation on columnar databases. So we also call in-memory database as in-memory columnar database. The complete name of Power Pivot, you can even call it like this: in-memory columnar database. Why we are calling in-memory columnar database means the data will be stored in which format? Columnar format. So when you perform any aggregate calculation on in-memory columnar databases, they are much faster when compared to row databases, guys. Second advantage is when we perform any aggregate calculations on in-memory columnar databases, they are much faster. They are much faster when compared to row database. To row databases. What I mean to explain is, what I mean to tell here is databases. So when we perform any aggregate calculations on in-memory columnar databases, they are much faster. So reporting is all about aggregate calculations, guys. Tomorrow when you join in any company, when they're asking to create a report, what they will ask you to show is, show me count of customers I have. Count is what? Aggregate calculation. Show me count of orders I have. Again, count is aggregate calculation. Show me sum of sales amount I received. Sum is what? Aggregate calculation. Show me sum of profits I received. Aggregate calculation. Reporting is all about aggregating the data. So most of the times in the reports, clients will ask us to show aggregate data only, guys. Aggregate data only. So what I am telling is, when you perform any aggregate calculations on in-memory columnar databases, they are much faster, not uh, one time or two time. They are much faster when compared to row database. Take an example. I have a table here, SQL Server sales table. The sales table contains 100 million records. 100 million records are there. From 100 million records, I want to calculate sum of sales. Sum of sales is what? An aggregate calculation. When it is taking 30 seconds of time here to calculate it, so 100 million records to some 100 million values, it takes some time. The same sales table is there here. The same 100 million records are there here. And when I create sum of sales here, it will give the data in 5 seconds of time, guys. That much faster you'll get the performance. These 2 points, I'll practically explain how you have this two at one. How the data will be come to 1 by 10th of source data, I'll practically show you. And when you perform aggregate calculations on in-memory databases, why they are much faster, we'll discuss, guys. We'll discuss. So on the whole, Microsoft design. So when I start Power Pivot module in the coming classes, I'll explain completely what is this row format, how the data will be stored internally, what is this columnar format, how the data will be stored internally. When you store the data in the columnar format, what are the advantages? First advantage is, as it processes the data from RAM, you can see the data quickly. Second advantage is data will be highly compressed. So how it, till what extent it will compress the data, so practically I'll show you. And when you perform aggregate calculations, they are much faster. How they are much faster, practically I'll explain every point. This is too early to understand, I'll discuss. On the whole, Microsoft designed Power Pivot database purely for reporting purposes. So rather than creating the reports directly on the SQL Server, when you do the reporting on Power Pivot, we will see good performance. Okay, so we understand the tool capabilities. Whatever I discussed so far, nothing to do as a developer here, nothing to do as a developer. It is the tool capabilities, Power Pivot capabilities. As a developer in the Power Pivot, as a developer, Power BI developer, as a Power BI developer in Power Pivot, will perform two activities. In Power Pivot, we will perform two activities. How many different activities you will perform? Two different activities as a Power BI developer. First activity in the Power Pivot you will do is data modeling, guys. First, what we will do in the Power Pivot? Data modeling. Second activity we will do in Power Pivot is enhancing the data model. Enhancing the data model. Enhancing the data model. So enhancing the data model is the place where DAX come into the picture. When I'm discussing enhancing the data model, you will try to understand what DAX is. So how it will be helpful for us. These are the two works we'll do in the Power Pivot. First, let's start with understanding about data modeling. Once you load the tables into the Power Pivot, I'm telling first work we need to do is in the Power Pivot is what? Data modeling. Let's talk about what is the data modeling. What is the data modeling? What is the data modeling? Let's understand, guys. Fine. The definition of data modeling is establishing the relationship between the tables. We call it as data modeling. Is simple. What is data modeling means? Once you load the tables, we'll try to establish the relationship between them. Relationship means if you look at this here, there is customers table and sales table. Between the customers table and sales table, you are seeing one line. So this we call it as relationship, guys. This we call it as relationship. So what data modeling means? Establishing the relationships between the tables. We call it as data modeling, guys. So let me write here first. Establishing the relationships. Establishing the relationships between the tables. Between the tables, we call as data modeling. We call as data modeling. Fine. Here, once you load the tables, why we need to do data modeling? So people will ask you, so when you tell them what you will do in Power Pivot, I ask a question, what you will do in Power Pivot? You answer that we'll do data modeling. Immediately I ask, why I need to do data modeling in Power Pivot? Why you need to have the relationship between the tables? If I don't have it, what is the problem? What is the problem? The question is, what is the need of data modeling, guys? Once you load the tables, what is the need of data modeling? And the same question some people will ask like this: what is the need of establishing the relationship between the tables? What is the need of establishing the relationship between the tables? So luckily, Power Pivot itself will do lot of data modeling work, guys. If you load, I loaded totally 9 tables. So have you established these relationships? No. So Power Pivot have the intelligence to do majority of data modeling work. Majority of the data modeling work will be done by which software, guys? Power Pivot itself. It have that intelligence. I'll discuss how it have that intelligence. So these tables you got the relationships. Even between these tables you got the relationships. So only here there is some missing relationship. There is an independent table here. When you load the tables, majority of the data modeling work will be done by Power Pivot itself, guys. Let me write here. One more point. Majority of data modeling work. In the older days, once you load the tables, everything a developer need to do it. So there is no this much intelligence to get these relationships in the older days. But these days, the tools have a lot of intelligence where they will do a lot of work. Majority of the data modeling work will be done by Power Pivot itself. Power Pivot itself, guys. How? How it is doing? Okay, we'll try to understand how it is doing that majority of data modeling work. This time, two questions. First question is, once we load the tables into the Power Pivot, we need to do data modeling. Why we need to do it? Second question is, when you load the tables into the Power Pivot, that majority of data modeling work is doing by Power Pivot itself. How it is doing? Let's try to understand one by one. First, let me explain what is the need of doing data modeling is. When company is storing some data, they don't store all the data in one table, guys. Take an example. I join in one company as a employee. I joined in my one company as a employee. When I join in one company as an employee, all my employee details will not be stored in only one table. One table. Sometimes you'll have multiple tables. Some details about employee will be stored in employee table. Some details about the employee will be stored in DEPT table. Some details about the employee will store in manager table, like this. So about one item will store the data in many tables. About one employee, all the details we never store in one table, we will store in multiple tables. If you look at this, same thing happens here. So I have three tables here. Employee table, where I have some basic information like what is the employee name and what is the job of that employee. Clerk is a manager, and what is the salary we are paying, commission we are paying, I have it. And the same employee, clerk, is working in which location, he's working in which department name, they are storing in another table, guys. So there, this, see, when there is an employee, they will work in either one location, Hyderabad or Bangalore or Pune or somewhere, right? So where, which location they are working, they are storing in another table here. Look at this, clerk. Clerk is working for which department? 10th department. All the 10th department employees, 10th department employees are working in which location? New York. 10th department employees are, department name is accounting and the location is New York. 20th department employees, their department name is research, their location is Dallas here. So here in this table itself, they're not storing their department name and their location, right? They're not storing here. They're storing in another table, Same way, for this employee, who is the manager? Manager name, they're not storing in this table. For clerk, the manager is 7839. Manager name is storing in another table. 7839 is nothing but what? 7839 is nothing but king. So all the times they don't store all the information in one table, guys. Take an example. My client is asking to create a report here. Show me employee name and in which location they are working. Employee name and which location they are working. Employee name is available in which table? Employee table. You need to take employee name from here. And location information is available in which table? Department table. So whatever the information client is asking to show in the visual here, client is asking to create one visual here. Show me in the visual, client is asking to show employee name. To get the employee name, where I need to go? Employee table, drag the employee name. Along with the employee name, I need to show what is the job for that employee. Adams is what? Adam is a clerk. Okay. And what is the salary we are paying for Adam? You can drag the salary. 1100 is the salary. Are we paying any commission to him? You can drag the commission. And in which department number he is working. So far, there is no issues when I drag these 5 columns. I'm showing Adams is a clerk. His salary is 1100. He don't have any commission. He's working in 20th department. Go and check it here in the EMP table. You can find all the information, guys. Adam is a clerk, correct? His salary is 1100, correct? He don't have any commission and his department number is 20. Till here, I'm able to show comfortably, guys. Along with this, client is asking to show in which department name Adams is working. In which department name Adams is working. In which location Adams is working. Where do you have department name column? Department table. Where do you have location column? Department table. You want to drag the columns from another table now. Now, before I drag the columns from another table, dname and location, intentionally I'll go and delete this relationship. We're trying to understand what is this importance of this relationship. Right click on it, delete it. I'm deleting it. Intentionally, I'm deleting it. When I delete it, these 2 tables are independent tables now. So client is asking to show the information from 2 tables. I want to show department name here. As soon as I drag the department name, my visual is showing the data? No. So when I don't have department name column, is it showing the data? When I'm taking the columns from only one table, it is comfortably showing the data. So 20th department employees are working for research department and Dallas location. I want to show that we know in the DEPT table, 20th department employees are working for research and Dallas location. That is what I want to show here. 10th department employees are working for accounting and location is what? New York. New York. I want to show that information here. So for that I am dragging department name, I am dragging location. Unfortunately, my visual is not showing. When I click on see details, it is telling a message cannot determine the relationship between the fields. You are trying to drag the columns from EMP table as well as DEPT table, and there is no relationship between them. The meaning of this message is you are trying to drag the columns from two different tables in one visual, and there is no relationship. That is the reason I am not able to show the data. Whenever we need to show the data from more than one table, so I'm using both EMP table and DEPT table columns in one visual. Must and should you need to have the relationships. Otherwise, it is not possible to show, guys. So if I want to see the data here, what I need to do is I need to go to model view. Model view is the place where you will do the data modeling work. Whenever we need to do the data modeling work, let me write here. So data modeling work will be done in the model view, guys. Data modeling work, establishing the relationships. Data modeling work will be done in model view, guys. Model view. You just need to go to model view. You need to do the data modeling work. Yes, okay, model view. So I'm trying to create the visual using EMP table and DEPT table. If you want to show the data, you need to have the relationship. You need to have the relationship. Select the department number column. How to establish the relationship is you need to have a common column. If you want to establish the relationship between the tables, you need to have a common column. What is the common column I have here? Department number and department number. Select the department number from one table, drag and drop on the department number in another table. Simple. When you drag and drop it, you got the relationship here. You got the relationship based on which column? Department number column. Now, will the visual will show the data now? Yes. When I go to the visual, I'm comfortably show Adams 20 department is research Dallas location and Clark 10th department accounting New York. Correctly it is showing. So whenever we need to show the data from more than one table, we need to have the relationship between them, guys. Why we need to do data modeling, guys? Whenever we need to show the data more than one table, we need to have the relationship between them. We need to have relationship between them. Relationship between them. Otherwise, it is not possible to show the data. The same way, in the same report, I want to show manager name also. For Adams, who is the manager? Manager, I want to show manager name also. Manager name is available in which table? Manager table. So I'll go and delete this relationship. Delete this relationship. And I'll go and try to drag the manager name here. Manager name here. Go to the product name. Manager. When I try to drag it, will it show? No, I don't have the relationship. If you want to see the manager name correctly, you need to have the relationship here with a common column manager. Manager. You need to go and establish the relationship. Drag and drop it. As soon as you drag and drop it, you got a relationship based on manager. Will you see the data? Yes. For Adams, the manager name is what? Scott. Like this, whenever we need to create a visual using more than one table, between the tables, we need to have the relationships. In the real time, majority of the cases we'll create the visuals using more than one table only, guys. So client will ask you to show each product, how much sales you are getting. Each product, how much sales amount you are getting. Client will ask you to show. When you want to show each product how much sales amount you are getting, you want to drag the product name from product data table. You want to drag the sales amount from sales data table. So when you want to create the visual using these two tables, you need to have what? Relationship. Then only you can do it. My client is asking to show customer name wise sales. Customer name, you need to take it from customers table. Sales amount column, you need to take it from sales table. If you want to see the data, you need to have the relationship, right? We understand what is the importance of relationship, guys. Now we'll go and understand how majority of the data modeling work is done by Power Pivot itself. So when you load the tables, between the tables, you got lot of relationships. That all these relationships is getting by the tool itself. How it is doing the data modeling work, let's understand, guys. How it is doing the data modeling work is, so there are some two settings in the report, guys. In the file menu, So just see the navigation in the file menu, options and settings, options, options. When you go to the data load options in the current file, when you go to the data load options, there is a section with the name relationships. In the relationships, there are two checkboxes selected. These two checkboxes are helping us to get this majority of the data modeling work done, guys. Let me write the navigation. I'll explain about the 2 points. File menu, you need to go to file menu. In the file menu, you'll find options and settings. You'll find options and settings. Options and settings. In the options and settings, you will see options. In the options, you will see current file. Current file. In the current file, you will see data load options. In the data load, you will see relationships, guys. Relationships. There you see two checkboxes selected. One checkbox is import relationships from data source on first load. Import relationships from data source. From data source on first load. On first load. Tell me, guys, what data source means? Import relationship from data source on first load. Okay, what data source means? In Power BI terminology, what data source means? From where we are taking the data, we call it as what? Data source. See, when you are taking the data from SQL Server is what? Data source. When you are taking the data from Excel is what? Data source. From where we are taking the data, we call it as data source. Remember, right? What we are telling? First checkbox, what it is telling? Import relationship from data source on first load. This option will work for databases case. This option will work for what? Databases. So when you are taking the data from databases, so basically SQL Server, Oracle, we call it as relational databases. In SQL Server, Oracle, what we'll do is we'll store the data in the form of what? Tables. And even between the tables, you'll have the relationships. In the database, you'll have tables, and between the tables, you'll have relationship. What we are asking is, when you are bringing the tables from database to the Power Pivot, not only bring the tables, bring their relationships also. The first option is telling import relationships from data source. When you are bringing the tables, not only bring the tables, even bring their relationships. So when a database contains tables and relationships, when you bring the tables, you will even get the relationships also. So if you observe here, this customers table, sales table, and product table, we bought it from which source? If you remember, this customers table, sales table, and product table, we bought it from where? SQL Server, guys. SQL Server. It is from SQL Server database. In the SQL Server database, these three tables have relationships already. That it will bring the three tables as well as their relationships also. We are clearly telling import relationship from data source on first load. For the first time when you are bringing the tables, if you have any relationship between the tables, bring that relationships also. Okay, fine. So when in a SQL Server or Oracle, tables will have relationships. If you observe here, I bought EMP table, DEPT table, and managers table from same. I'm not this time. These tables are not coming from database. If you remember, we bought this EMP table, DEPT table, and managers table from where? Excel. Excel. So in Excel, do you have the relationship between the tables? Excel independent sheets. You don't have relationships. When you even bring the tables from Excel, you got these relationships. So will this first option will work? Means no, guys. So only first option will work for what kind of sources? Database related sources. The sources which have relationships, there it will work. So there is second option there. Second option is auto detect new relationships once data is loaded. Once data is loaded. What this option? This will work for all the data sources, guys. It will work for files. All the data sources means what? It will work for files. It will work for databases, etc. Every data sources, etc. So what this option will do is auto detect new relationships once data is loaded. What this option will do is Once the tables are loaded into the Power Pivot, it will read how many tables I loaded? 9 tables. If you remember, I loaded 9 tables. It will read every table, each and every table. Between the tables, if it find the common name, it will establish the relationship based on the name, guys. So when it is reading 9 tables, between EMP table and DEPT table, it find a common name called department number. It will establish the relationship. So when it is reading the 9 tables, between EMP table and managers table, it find a common name called manager. It will establish the relationship. So take an example. This product table is coming from where? SQL Server. This EMP table is coming from where? Excel. There is a same column name with the name ABC. There is a same column name with the name ABC. The second option will even establish the relationship between these two tables. Second option is what? Auto detect new relationships once data is loaded. It will load each and every table in the Power Pivot. If it finds the same column name, even though they are from same data source or different data source, it doesn't bother. If it finds the same name, with that name, it will establish the relationship, guys. So when it's a file system, this second option will work. When it finds the same name, it got established the relationship. When it finds the same name, manager and manager, it got established the relationship, guys. These two options together will help us to do the majority of data modeling work. So by mistake, if it miss any relationships, we need to go and establish it, guys. About data modeling, I'll discuss for 5 hours of time, guys. So if you observe here, only about data modeling in the coming classes, we'll discuss for 5 hours of time, guys. We'll start Power Pivot. First, we will discuss clearly about in-memory databases, and we'll start about data modeling part. In the data modeling, we'll discuss about data warehousing concepts. What is dimension tables, fact tables, types of cardinalities, types of schemas. So extensively, only data modeling itself, important, guys. We'll discuss about 5 hours of time. What are the schemas? Which schema will give better performance? All this we'll discuss for 5 hours. For now, at a high level, I explain once you load the tables into the Power Pivot, what we need to do. Lot of things we will do in data modeling. It is not simple, guys. 5 hours of time we will just discuss about the data modeling itself. So even though when your tool is doing this data modeling work,
Can you tell me about visualizations?
I'll discuss what you want. I'm not getting the question. What? What is the question?
Visualization.
Visualization I will discuss. I'm not yet there. He's asking to explain directly Power View visualization. We are discussing. We are coming there. Wait for some time. Fine, guys. So first we seen how to load the tables. As part of data modeling, you need to understand a lot of things, guys. What is this cardinalities? All this. You need to understand a lot of things. We'll discuss for 5 hours of times in the coming classes. For now, we understand at a high level. So when you load the tables, where you can see them. And so as Power Pivot is a database, you can see the tables, and in the tables, you can even see the data. Power Pivot will store the tables along with the data. And once you load the tables, how to establish the relationships we see in it. So that means we are done with data modeling, guys. Once you are done with data modeling, you can start creating the visuals. You can start. So the data is there in the form of tables here. If the client want to understand this data, you need to present this data in the graphical format, guys. So data in the tables will be in the form of tables. Data will be in the form of columns and rows. The end user want to understand the data, you need to present that in the graphical format. Where we will do that is in the Power View, we'll present the data in the graphical format, guys. Now, so once you are done with data modeling, once you start creating the visuals, we can create only 70 to 80% of visuals, guys. Once we are done with data modeling, when we start creating the visuals, we can create hardly 70 to 80% of visuals. Hardly 70 to 80% of visuals. What I'm trying to explain here is You load the tables, you are done with data modeling work. Once you are done with data modeling work, if you go and start creating the visuals, whatever the data you have in the data model, when you start creating the visuals, you can create only 70 to 80% of visuals what client is asking. Let's take an example. Client is asking to create 100 visuals. So to create this 100 visuals, I loaded the tables into the Power Pivot. I did the data modeling work. With the data model, out of 100 visuals, I can create only 70 to 80 visuals. 80 visuals. With the data model itself, it is not possible to create 100 visuals, guys. 100 visuals. See why it is not possible. Take an example. There is an orders table. Orders table is there. I have some orders related data in this table. My client is asking to show what is the total sales amount we have. If you want to show total sales, I can go and take one visual. I can take one visual here and I can show the sales amount column. I can go to the orders table. I can drag the sales column. I can show it. Yes, perfect. The total sales is 2.3 million. I'm able to show it. As I have the sales column, I shown it. Now my client is asking to show each region how much sales amount you are getting. So each region, okay, I'm doing the business in 4 different regions. Each region how much sales amount you are getting. When you want to show each region how much sales amount you're getting, you have a region column, you can drag it. You have a sales column, you can drag it. When you drag region and sales, each region how much sales you are getting, you are able to see. So along with the region and sales, my client is asking to show percentage of sales here. Each region how much percentage of sales it is getting. Percentage of sales means central region sales divided by all the 4 region sales into 100 will give the percentage of sales. So percentage of sales column will not be readily available in the sales table. When you go to the orders table, when you go and check it here, you don't find percentage of sales. Client is asking to show some information called percentage of sales. This visual is incomplete. When they're asking to show region wise sales, I have region column, I dragged it. I have sales column, I dragged it. When they ask you to show percentage of sales, I don't have a percentage of sales there. I'm not able to show it. Client is asking to show year wise sales now. When client is asking to show year wise sales, I'll go to the order date. I'll drag the year. Total is 2.3 million. I want to understand in each year how much sales I'm getting. So I can drag the year, I can drag the sales. Each year wise sales it will show. So now my client is asking to show year over year growth, percentage, year over year growth. So I want to compare previous year sales with current year sales. This year, how much growth I have? 2016 year, how much growth I have? I want to compare current year sales with previous year sales. I want to get the growth. Percentage year over year growth is common. When you go to the meetings, they'll tell that when compared to previous year, this year we have a growth of 30%. I want to show percentage year over year growth. When you go to the orders table, you don't find the year over year growth directly available here. So percentage year over year growth formula is current year sales minus previous year sales divided by previous year sales into 100 will give the growth of the business. They're asking to show it. Sometimes whatever the information client is asking to show in the visuals, percentage sales, percentage year over year growth, you don't find that information readily available in the tables. Whatever the information is available in the tables, even the less knowledge person who have very less knowledge about Power BI, he can even create the visuals. To create this 70 to 80% of visuals, you don't need to learn much things, guys. Even less knowledge person can even create it. To create remaining 20 to 30% of visuals, I said that showing percentage of sales, showing percentage year over year growth, lot of additional information will show it. To show that kind of information, we need a skilled person. Here, the data model which I developed is not supporting me to create 100% of visuals. In that case, what I need to do? So I want to go and do the second work now. I want to go and do the second work, enhancing the data model. As my data model which I developed is not supporting to create 100% of visuals, I want to make some changes to my data model. I want to make some enhancements to my data model in such a way I can create 100% of visuals. Enhancing the data model definition is, enhancing the data model is nothing but creating new information using existing information, guys. Existing information. We need to create some new information using existing information. My client is asking to show percentage of sales here. Percentage of sales is a new information what I need to show. My client is asking to show percentage year-over-year growth. That is the new information what I need to show. Do you have that in the table? No, it is not there, but you want to show it. So when you want to show percentage of sales, you don't want to bring the information from outside, guys. Is there any need to bring it? No, you just want to use that region sales divided by all the region sales. Whatever the new information we need to create, we'll use existing information only to create it. Even to show year-over-year growth, do you need to bring the data from outside? No. To get the year-over-year growth, current year sales minus previous year sales divided by previous year sales into 100. So always you need to create the new information using the existing information which is available in your data model, right? Enhancing the data model is nothing but creating the new information using existing information. So whenever you are creating the new information, only existing information is not sufficient. Along with the existing information, we need to use a functional language called DAX language, guys. In the process of creating the new information, what client is asking, only existing information is not sufficient. Along with the existing information, we need to use one language called DAX. DAX stands for Data Analysis Expressions Language. Analysis Expressions Language, guys. Data Analysis Expressions Language. We usually call it as functional language. Functional language. So it is also one computer language. How you have C language, C++ language, SQL language. Same way DAX is also one computer language. What it contains is DAX is all about functions. Majority of the DAX is all about functions, guys. If you look at this here, so D drive, Power BI material, Power Pivot, DAX. DAX is all about functions. DAX functions. There are different categories of DAX functions. When you go to each category, time intelligence functions, you'll find lot of different functions. Total MTD, total QTD. If you want to get previous year sales, you want to use a function with the name what? Previous year. You want to use a function with the name previous year. Previous year. Like this, what information I need to derive? Based on the information, what information I need to derive? I need to go and use some functions. I need to derive it. There are a lot of different functions in the DAX. We need to learn all these functions. Tomorrow's class, I'll explain about DAX, guys, how to create the new information. So I said that I want to show percentage sales rate, how to create it, how to use the DAX while creating it. We'll discuss in tomorrow's class. So for now, keep in mind, DAX language is all about functions. It is not difficult again. It is not difficult again. DAX is just, you need to learn what are the different functions you have, when to use them, how to use them. If you know, you can easily derive the new information, guys. In the process, whenever we need to derive any new information, we might need to use some functions in the DAX. With the help of that functions and existing information, we will derive it. When to use that functions, how to use that functions, we need to know. In tomorrow's class, I'll discuss more about the enhancing the data model. We'll stop here for today. We'll continue from here in tomorrow's class, guys. Let me conclude.